little electric car that couldn't, the Wheego, is dead. Several months ago, during the winter, while my shop was being worked on, I left the Wheego outside in the cold. And I left it outside for just a little bit too long. Long enough for the onboard computers, i.e. the BMS modules, etc., to drain the main battery pack of the car down to almost dead. Well, to the onboard car charger, almost dead is as good as dead, and it refused to charge the battery after this point, which means that now the battery pack is totally dead. So now the task is to drop the battery pack out of the Wheego for two reasons. One, to remove and inspect each individual battery cell, all 36 of them, to see if any of them can be saved or if they're all a total loss. And two, to see what lies waiting between the battery pack and the body shell. Because if you remember, the Wheego is based on a Shuanghuan Noble body shell, and supposedly, to make that battery pack fit in there, Wheego hacked away at the unibody structure of this body shell to shove it in there. So I'm excited to see what sort of hack jobbery lies in waiting for us between the body shell of the car and the battery pack. So let's get started. It looks like there's just 6 bolts holding this entire battery pack into place underneath the car here. They're very large bolts, but there's only 6 of them. So I guess not a whole lot to undo. Plan of action here is pretty simple. Drop the entire car body shell with the battery pack attached to it down onto my little heavy-duty cart here. By the way, if you want to see how I made this cart, I made a video of it on my second channel. I'll put a link somewhere. And then unbolt the 6 bolts that retained the battery pack to the car, drop the battery pack down onto this cart, and then lift the car away with the lift. Pretty straightforward. I'll have some cables to disconnect in there, but shouldn't be too awful, unless I get electrocuted, and then it would be awful. Lower it down until it just barely makes contact. All right, let's start undoing some bolts with my whizzy doohickey. There we go, last bolt removed, I think, unless there's more bolts somewhere that I don't see yet. All right, let's gently raise it up, which is very difficult to do with this lift because it's just a push button. It's not variable speed at all. Battery pack is going up with it. What did I do wrong? There are 2 bolts in the middle of this battery pack down here, and I'm going to undo them. Not because I think they're actually holding the battery pack in place, but because something's holding the battery pack in place and I don't know what it is. So I might as well just remove these 2. I think that's all the bolts now. Okay, so there may have been 8 bolts holding this in rather than 6. 2 of them were rather small. Very, very long, but rather small. Pulse it upward. Oh, battery pack seems to be lifting away now. And by that I mean dropping out, not lifting away. The car's doing the lifting. Battery pack is now loose. So let's get him back here and see what cables I need to disconnect. Wow, there's a little connector back here that, no joke, is being held on by electrical tape. Here it is. I disconnected the high voltage leads to the car and the high voltage leads to the charger. Well, from the charger to the battery. And there was one other connector in there, and I think I have everything. So I'm going to rise it up slowly and check every inch or 2. All right, I disconnected 3 more connectors. I think that's it now. Here it is, the battery pack. And here's the battery pack outside of the car. Surprisingly, it's not as bad as I was expecting it to look. I was expecting it to look like it was built by an 8th grade shop class, but it looks like it was hand fabricated by a somewhat professional company. That's the key thing to note there, is that it looks like it was hand fabricated. Does not look like it was mass produced. It's all thrown together with very thick aluminum, and all of it is welded. And there's some afterthought looking stuff here, like this thin sheet of acrylic that covers up something. There's these 1/2-inch thick slabs of aluminum here and here that look like they were tacked on later. It's filthy. There's no weather sealing. Everything's just exposed to the dirt and road grime and everything that gets up around the sides of the battery pack and on top. And I'm sure the LiFePo Forces cells in here will be fine. they're not going to be damaged by all of this dirt getting in here, but I'd like to see the electronics not covered in a layer of filth. That would be nice, even if it doesn't really do anything. Oh, the pristine cells underneath, well, pristine-ish. They're still very dirty on the edges. But look at them. This is just a cover. Why is it so heavy? Again, hand fabrication. It's very wonderful in here, but there's some blocks of Delrin in here for locating the batteries, and there's some grooves routed in them for wire passages. Very clearly handmade for this and not mass-produced. But it's interesting to see. Each one of the 36 lithium iron phosphate battery cells in this battery pack is rated at 3.2 volts nominal with a charging cutoff of 3.65 volts. That brings the entire pack voltage up to 115 volts nominal. However, I just took a reading of the entire pack voltage, and the entire pack altogether is reading a whole 21 volts right now, which, as you may or may not know, is substantially less than 115. So it's dead. Cell 1. Only 35 more to go. Look, a little temperature sensor. That's cute. You know, I make fun of the build quality of this thing, but at least all the BMS modules and contactor here are on one nice, big, easy to remove, and extremely filthy plate. Just this haphazard block stuck in here, keeping the plate off of the contactors. Okay, so that's what this sheet of acrylic was for. It was making sure that big aluminum plate that's sitting on top of here doesn't short out all the batteries. Oof. With this nice piece of what I assume is Delrin to keep the middle of the acrylic from bowing down. Lovely. All right, I figured out what these big fat slabs of aluminum are for. They appear to just be squishing the battery pack this way. That's the only purpose it seems to serve. What's up? I'm amped. I made a cell tower. Please don't leave. I got all the cells out of the battery pack, and now it's time to go through, check the voltage of each one, and sort them into like voltaged piles. I had to poke around at some of the cells while they were still in the battery pack, and all of these cells are at wildly different voltages, so some sorting is in order if I want to make charging a little bit easier. Besides, I need to check the voltage of each cell anyway. And here we are. I have gone through and measured the voltage on each and every cell, and then written it on a little piece of masking tape, and then gone through and arranged every battery cell from least charge to most charge. The least charged cell over here is at a paltry 0.15 volts. So basically dead. And then the most charged cell over here is 1.32 volts. Now remember, these cells are rated at 3.2 volts nominal, so all of them are very low. Some of them, like this 0.15 example over here, probably completely dead and unrevivable. Now for charging them, what I'm doing is the easiest thing I could think of. My battery tender here has a LiFePO4 setting, conveniently, lithium iron phosphate. It's charging them to 12 volts, so I have the 4 most charged cells over here linked together in series, and then I'm charging them as a bank of 12 volt battery. While the batteries are over on my workbench doing their large and charging thing, let's take a look at the underside of the Wheego, where I regret to inform you that it's not as interesting as I was hoping. About a year ago, I made a video touring the undercarriage of this car, showing you how badly this thing is made, showing you all the heinousry, hack jobbery, and botch jobs that make up the underside of this car. And naturally, well, all that stuff is still here. What's disappointing is that removing the battery pack didn't really reveal anything new. I mean, sure, I can more easily see things like these hilariously hacked together mounting points, and where they cut away the floor of the car back here with what looks like a plasma cutter or maybe a dull chisel to make room for the upright section of the battery pack. But there's not much new to behold. So unfortunately, if you want to look and gawk at some bad workmanship, you'll have to go watch that old video. And the reason for that, in the back section anyway, is mostly because Well, there's nothing above the battery pack. Normally, the only thing separating the top of the battery pack from the inside of the car is this piece right here, which is just a piece of particle board with some carpet glued to it. And since this is in my hand right now, I'm looking at the inside of the car from underneath it because there's no floor back here. They cut away the floor in the back to make room for the upright section of the battery pack and put nothing in its place other than this board. And above the front part of the battery pack, the shallow part of the battery pack, is just the floor of the car. Nothing too interesting. I mean, it's kind of interesting how weirdly high up this floor pan is. Look how deep these sills are. It's like 3 inches here. And maybe that's one of the driving factors, one of the reasons that Wheego chose this body shell to make their electric car, because there's a weird amount of room under here to slap a battery pack underneath. But aside from that little fact, it's just the floor of a car. Hello, it's been about 2 weeks since we last spoke, because that's how long it's taken me to charge all of these cells. And I don't know what the last thing I said was, but let me tell you what I did. I went through from most charge to least charge, and I wired these cells up 4 at a time in series and charged up these banks of 4 cells, all 9 of them, with the battery tender until each cell was at about 3 volts. And then I went through in the other direction, wired them up 4 cells at a time again, but this time in parallel. So I had basically a larger bank of 3.2 volt batteries, and I charged them up 4 cells at a time with the DC power supply at 3.6 volts until the amperage dropped down to about 5 amps, which meant that the cells, each one of them, was charged to somewhere between 3.20 and 3.24 volts. And I did that for all 9 packs of 4 cells to the end. So now all of these cells have been charged to somewhere between 3.20 and 3.24 volts. Really just all depended on where I decided to cut off the charging. And they've been sitting for several days since then, and none of them have dropped voltage significantly. All of them have dropped voltage at least a little bit, but none of them have dropped voltage significantly. So what I've decided to do is, instead of trying to weed out any bad cells or do any sort of testing on them, I'm just going to take all of these cells and chuck them back in the battery pack. Reassemble the battery pack, chuck the battery pack in the Wheego, and see if I have a functioning car again. I'm just going to try it, because if I try to weed out any bad cells, what am I going to do to replace them? I can't get replacements for these. I looked. I could not find direct replacements for these cells. So if I weed out any bad cells, that means I'd have to replace the whole battery pack, all of the cells, or have a non-functioning car. So I'm just going to chuck these back into the Wheego and see if we have a functioning car again. Join me. First cell. This is how you properly treat batteries. Well, that's all of them in place. Now I got to do the wiring. I'm going to do that off camera because I'm going to have to focus on the pictures I took a bit. All right, all that wiring is done. It wasn't hard. I just had to reference all the photos I took and make sure I put everything back the way it was. I don't know if I pointed this out earlier. Did you see how all these BMS modules are connected to the cells? Into the big bolts where the battery cells are connected to each other, they drilled and tapped little holes so they could put a little tiny bolt for these BMS cables. I thought that was kind of neat, an interesting solution. I swear this thing was made out of components from Home Depot. This battery has bowed a bit. I hope that's not a problem. It's a bit balloony. Last cell. This is a little bit more than a cover. It also clamps the cells down in place. So I guess that's the reason it's so big and heavy. Bloop. And to install the anti-short circuit mat, a piece of plastic. And hopefully you'll be able to tell that I cleaned up this board a bit, because it was very dirty and very bothering me. Well, they're all pulsating like they should, so that's a good sign, is what that is. Okay, with any luck, this Wheego should just drop straight down onto the battery pack, almost entirely aligned. I say with any luck, I just spent about an hour off camera lining the two up, so it should be in alignment. Now all I gotta do is bolt it in place and clip all the clippy bits together. Up you go. This is the positive live from the battery. This is the negative. The positive goes through a fuse right here, which is disconnected, and the current meter shunt resistor metering thingy, and connects up to the contactor here. This is the live side of the contactor. This is the switched side of the contactor. These cables go to the drivey bits of the car. They're on the switch side of the contactor. And these two cables are for the chargers, or from the chargers of the car, and they go to the live side of the contactor. And that's it. There's some communication leads over here as well, but I already plugged those in. Now, the only thing I have left to do to make this battery pack live and connected to the car is to swing this fuse over and connect it right here. But I have one last step to do before I do that. The old 12-volt battery was dead, so I got this new one to chuck in here. I just need to install that, and then we'll be good to go. Ooh! Fired to life! Oh, that scares me. Okay, everything's connected. Let's turn the key on and see what happened. Put it in park. All right, ready? Battery pack says, or the state of charge says 63%. I can't rely on that at all. Let's put on the brake and try to start the car, which just means open the contactors for the main motor. It worked. All right. Will it move under its own power? Oh, yeah. It can move. I'm weary. Let's take it out for a spin. I'm driving the Wheego again! It's full throttle. Said it was putting out a full 550 amps. It seems like I'm good. Now that's not the end of the story. I still have a few things to check out. The state of charge meter is completely meaningless right now. It says I have 63% battery, but in reality, the BMS modules are not talking to the dash. I'll have to call Wheego and see if I can sort that out. Also, I need to test this car driving it around more thoroughly. I could still have bad cells in there, but I won't know it right off the hop. And I need to plug this car into a charger and see if the onboard car charger works, and we'll put charge back into the battery. But as of right now, it works and everything is good. All I had to do was charge up all the cells individually outside of the car. So, let's do a little loop around the block in celebration. I'm back in the Wheego. 3, 2, 1, let's gun it. Tire squeal. The Wheego's back. And slow as ever. There's 40, 45. Okay, it wasn't this slow before, actually. Yeah, it could maintain 50 up this hill before. 45. I need to turn around now. I need to get back home. Let's pull off on the shoulder. I do not want to get stranded. Pull a Yui on the highway. Uh-oh. It's making groaning sounds. I made a mistake coming out this far. Like I said, first impressions mean kind of nothing. Well, that didn't go very well. It had to be towed back home. So it looks like the Wheego cannot be revived. But I'm not willing to pronounce it dead just yet, because I'm stubborn. And when I got it home, it is taking a charge. I was also able to drive it into the shop, so that's a positive sign, I guess. Maybe. Anyway, it's taking a charge, so I'm going to cycle charge it for a couple of weeks. Let it charge overnight, then let it sit off the charge for a day, and then charge overnight, and just on and off. And maybe that'll do something. I don't know. It's probably just a waste of time. But then, after I do all that fiddling about, I'll make a follow-up video where I will officially pronounce it dead. Almost certainly. There's no hope for this battery pack. The inflated battery cells should have been a sign of that, but I'm stubborn and had to try it anyway. Not all projects are successful. That's just a reminder of that. I mean, I tried to fix this car for basically free. The only money I spent on this project was the $50 12-volt battery up in the front. So really, no harm, no foul. Then I'll have to figure out what to do with this whole dead car. Anyway, thanks for watching. I'll see you next time. And thank you, patrons. Wheego.